Oh, there we go. There's the bell. All right. Okay, all right. So there's the do now. All right. So press pause, do the do now, use a calculator. Okay, and then we'll come back and go over it. Okay, all right. Let's see. Let's go over this now. Let me go ahead. Let's write down the formula first. What's now? First of all, you gotta recognize the shape before you use the formula. So this is a trapezoid. What's the formula again? See if we can remember right before the quiz. Yep, base 1 plus base 2 times the height divided by 2. Right, so let's see, base 1. So again, you notice how I'm rewriting this. All right, base 1 plus base 2 times 8 divided by 2. Let's do all that. All right, I'm going to use my calculator too. So let's see, 22.5 plus 28.7 is 51.2 times 8. It's 409.6 divided by 2 is 204.8. Okay, all right. 204.8. Okay, all right, done. What else? Let's see, Unit 8, Day 19. So you got a quiz today. So I'm gonna stop it at 20 minutes at most, okay? If not 15 minutes, and then give you the rest of the time to do the quiz. Okay, remember, take your time, do the quiz, okay? That's it. Okay. All right, let's see. No homework tonight, right? Because today's Friday, right? No homework. Okay, all right. Let's see. I didn't hear any feedback on the background music. Okay, so maybe no background music then. Yeah, it's too distracting. I mean, I when I watch it the second time, like I couldn't concentrate. So never mind. All right. There's probably no bonus question from the quiz today. Okay, because I'm actually shooting this video on a Thursday, so I haven't made the quiz yet. So if there is, you'll see it. All right. Let's see what else. Okay. All right. Next Monday or Tuesday, I'm gonna email your parents your grades again because it's been 2 weeks actually. So, yeah. So okay. All right. Okay. Let's get on to today's lesson now. Last lesson of this particular topic are trapezoids. Oops. No, that's yesterday. Okay. So today we're gonna talk about the last of the quadrilaterals, the parallelogram. Okay. So now let's take a look at this. Right. What's a parallelogram? So let's talk about the definition. One is it has 4 sides, right? And the second thing is, whereas the trapezoid, remember what I said? You have only one and only one pair of parallel sides. Remember what I said about being parallel, right? Meaning 2 lines that never intersect. Parallelogram's a little different. It has 2 pairs. 2 pairs of parallel sides. So that's the difference. Okay, so meaning right here, we got 1 pair of parallel sides. So these 2 lines are parallel, but so are these. And these 2 lines, these opposite sides are parallel also. Okay, so that's a parallelogram. Now, with that said, right, so here comes our old buddy Socrates, right, the great Greek philosopher. All right. By the way, if you want to read about his life, fascinating. Okay. All right. Now, let's compare this to a trapezoid. And what we'll do is we'll also compare this to a rectangle. And then we'll compare this to a square. Okay, so now they're all gonna face off against one another. Okay, so see if you remember, okay, without looking, because today is a bit of a review also. What's the difference between a parallelogram and a trapezoid? All right, I literally just said it. Yeah, 1 pair of opposite sides, right? So Whereas in a parallelogram, opposite sides are what, parallel. Okay, in a trapezoid, only one pair, only the base 1 and base 2 are parallel. Okay, now having said that, if you compare a parallelogram with a rectangle, how are they different? Because think about this, right? So our old friend Socrates would say something like, well, these opposite sides are parallel, and so are these opposite sides, right? So how are they different, right? Because this definition is not sufficient to explain something at the occurrence of a rectangle. Do you understand what I'm saying, right? Like, look, if you say there are 4 sides, okay, a rectangle is 4 sides. And if you say something like, well, 2 pairs of parallel sides, yeah, well, so does a rectangle, right? What's the one distinction between a rectangle and a parallelogram? Yep, you got it. It's the presence of right angles. They have like these 90-degree corners. That's what separates a rectangle from a parallelogram. Now, mind you, a rectangle, it's a parallelogram. Okay, so you see how the opposite sides are parallel? That makes this a parallelogram. It's just that a rectangle is a much more refined version of a parallelogram. Okay, because parallelograms doesn't need to know what the angles are. Okay, so the parallelogram doesn't need to know what the angles are. A rectangle has very strict ideas about the angles. They have to be 90 degrees. Otherwise, it's not even a rectangle. Okay, now let's look a little further. Here we got a square. So here's the thing, right? The square can make the argument, and the square can say, hey, look, I'm a parallelogram too. Why? Because my opposite sides are parallel as well, right? And so now the argument is, okay, like what say you then, right? With regards to how different a square is from a parallelogram. One is the presence of right angles again, right? But then comes the argument from the rectangle, because the rectangle now say, wait, hold on, then aren't we the same, right? We have both have 2 pairs of opposite sides, right? The square has 2 pairs of opposite sides, and all my corners are 90 degrees, right? And all the square's corners are 90 degrees. So how is a rectangle different from a square then? Right, a square has all 4 sides that are the same, right? All 4 sides are the same. In a rectangle, only the opposite sides are the same, congruent, right? That's that symbol, the congruent sign. So you see how even though in the way that I give you the definitions, that the more specific you get, it becomes different manifestations in terms of shapes as far as quadrilaterals go. Okay, so I'll repeat. In the way that, wait, what did I just say? Hold on. Using strictly the definitions, you will see how the minor variations in the definitions, right, it will manifest in different quadrilaterals. So again, right, a parallelogram, if only one opposite pair of sides are parallel, you get a trapezoid. If both pairs of opposite sides are parallel and all the angles are 90 degrees, you'll get either a rectangle or a square. And if you get even more specific, where all 4 sides are equal, then you don't have a rectangle, you got a square. Okay, so that's where that comes in. Okay, so hopefully that's a fairly comprehensive and understandable way of doing this. Okay, now having said all that, now I gotta erase all of this. Hold on. What do I do? Okay, all right, no, I'll just leave it here. Okay, so let's talk the area formula for a parallelogram. So what's the area formula of a parallelogram? Let me clean this. Let me clean all this up first. Very easy, super easy. Okay, so let's say this is the base and this is the height, right? I'm not doing anything crazy here, right? Like nothing new here, really. All the formula for a parallelogram is the base times height, and that's it. All right, can you hear the crickets? All right, that's it. I'm not gonna have you divided by 2 and times, the height again, or have base 1 plus base 2. Like there's no such thing. Just this base times height. Okay. Now, many of you might say, "Hey, Mr. Ing, how come this is so easy to memorize, right? Because this reminds me of a rectangle, right?" And you'd be right. Because remember with a rectangle, we did length times width, but then I said, "Hey, look, you can actually change this to base times height." And that's exactly what this is. So the area of a rectangle is length times width, or the same thing as base times height. So in other words, this is going to help you remember this. Think of a rectangle, right? Let's say there's a very strong tropical storm or a very gentle breeze, right? Let's say, right, the wind just kind of blew at the rectangle here, and the rectangle got tilted out of shape. That's what you would get. You get a parallelogram, right? So if, like a hurricane came in, right, and the wind blew right at the rectangle to the right, that's what you would get. You get a parallelogram. So why wouldn't the area be just base times height? Okay, think of it like that. Now, besides that, the other way to remember it is to think of this. All right, so this is not a this is a slight magic trick that I'm performing. So here, what I'm gonna do is you see how I form a triangle here, right, with the height here. What I'm gonna do is I'm gonna cut off the triangle here. See that? Okay. All right. And then what I'm gonna do is I'm gonna move this to the other side. What do you notice? Yeah, now I have a rectangle, right? See that? So again, base times height. That's it. Base times height. You get a rectangle. And also, if you are willing to move the parts around, you will get a parallelogram. Okay, so that's the lesson. Okay, so let's fill that out. Let's go to the graphic organizer. Where is it? Did I miss it? Oh, it's right here. So let's write that in. All right, what's a good color? Something bluish. No, that's too close to the all right, blue gray. Yeah, all right, okay. So let's see, what's the shape? Parallelogram. Parallelogram. All right, not the toughest formula to remember, but probably by far the toughest word to spell. Okay, all right, so what is it? Area is base times height in a parallelogram. So let me draw a parallelogram. All right, let's see. Now, there we go. Now let's do it here. Yeah, okay, all right. So what's a parallelogram? Let's see. What color was that? Let's see. Okay. All right, here we go. Let's see. So this is the base. All right, and let me draw, I'll just draw a line like this. Not the best. Okay, all right, base times height. That's it. All right, that's how you do it. Okay, and this is complete. All right, and hopefully you use different colors too for each different section. It just looks better. Okay, now how are we doing on time? Oh, wow, we're at 15. You know what? Let me stop here then. Okay. All right. So I'm gonna stop the lesson here. Monday, when we come back from the weekend, we will go ahead and do some practice. Okay. So let me show you. So we'll do these sort of questions. Okay. We'll do some extra practice, and then that's it. And then Tuesday we'll move on to the next topic. Okay. All right. So that's it. There's parallelogram. Go ahead, do the quiz. Take your time. Okay. I haven't made the quiz yet at the time of making this video, so I can't ascertain how easy or difficult the quiz is. So take your time. All right. Use a calculator. All right. And okay. All right. Thanks for watching. Have a good weekend. I will see you guys Monday. Bye bye. Okay. Oh, there we go. There's the bell. All right. Don't tell me you don't miss that bell.
OMG, that was so good.